Remind. So data split into the number of blocks. Each block has a much bigger than the operating system block, like the 64 megabytes or 128 megabytes. Then later, eventually, we will use such a block for the unit of processing. So our processing will be also distributed based on the distributed data block. So each block will be accessed by the, which is called the task tracker. It's a demand process to process. Okay, like I wanna sum up the, I wanna count the number of words from the file. At the time, this one is the first block of the a.txt, and this one is the second block, and the two process is accessing the file, the block, and the count number of word, and eventually we will combine. That is the idea of the map reducer. So this header, the block will be used for the processing later. Okay. And this is our concept. So I already explained such a, in addition to the map reducer and HDFS, we need to consider the yarn is one more the core component, the common component, and on top of that we have a number of the application which is called the header graphical system. This is the overall thing. So keep in mind, the header distributed file system is running on the general purpose file system, like the ext3, foo, or xfs, ufs, the HDFS, any UFS, such a file system. On top of that, it's called the native operating system or the primary operating system. On top of that, we have the HDFS. Okay. Then we are using much bigger size of the block here like that, and we are going to take out any housekeeping job as much as possible from the each data node to the naming node. So naming node is a master node. It's a single point of failure. Because of that, we have the nowadays copy of that. Okay. So each block will split to the number of blocks. So mostly 3, it can be configured. So if you want, you can the 4, 5, and so on. And number 2 block, and like that. Who knows that this one? Naming node has the all metadata information. Okay, that's the naming node. I will explain that later. This slide shows the example of how to store the data first. If you want to access the file, this one has the 5 blocks. So B1 is in the A, B, D node. A and B and the D node. And B2 is in the B, D, E. Here, this file is in the B1, B2, B3, 3 block. And the next file is a B4, B5. And each block has at least 3 of them. So naming node knows which one is using the heartbeat, keep checking the response time. Which one is the fastest and slow. And the nearest one will be assigned like A for B1 and the B for the B2 and the A for the B3 and so on. So in the next version, the header 2, they support the standby node, but finally, version 3, they support a number of the naming nodes. So we can use the header, the share command. Sometimes it's header fs command or the hf share. The command are the same name. So you can see there's something popular. The command like put, ls, and move, and so on. So you will practice this one in the next class, the next week during the exercise. You can create a new directory on the HDFS and also remove the file or recursively. And so if you are familiar with the command line interface, pretty much very similar interface and the name. Okay. Very similar things to total file system, right? So So it's actually because of this one, I assigned that project to the operating system. It doesn't support the random access. What is a random access? Using address directly access the data. Most of the file systems support random access, but this is not. Instead, this one is sequential read. Our purpose is not such an online transaction processing. Instead, the huge amount of job, mostly I/O job. Okay, the next thing is the map reduce. So finally, we have the distributed file system. Then how we can use this one? So one of the approach is using the Hadoop shell, HDFS or HDFS shell command using you can directly access like the command line. But I want to do the programming. I want to put my algorithm to do that. At that time, we can use the map reduce. Map reduce is the programming framework for Hadoop distributed file system. Okay, so based on the divide and conquer. Let's say a.txt file has the number of words like the description and this one. I am a student. Okay, and also I like a baseball. For example. How many I? 2. How many A? 2. Then the others one time. On M 1 and the like 1 and so on. I want this kind of output. Okay? Then this is the first block. Second block is the I am going to Bridgeport. It's the second block. So if I add this block, then I is 3, and M is 2, and the 2 and the Bridgeport like that. This is what I want. So once we upload this file into the Hadoop distributed file system, this one will be A1 here, and the copy of this one, and this block will be here A2 and A2. Then what we want to do is we try to count number of words like this. So at this time, if we want to do so without considering this one, how can we count number of the words? We need to first make the I. M1. M1. A1. Student 1. Whenever you have a word, you need to search whether there exists. If there exists, like I plus 1, and so on. This is what we are thinking. But in this map reduce programming, what we want to do is always, this is a very important concept, key and value. We consider data always key and value. What is a key? That's what we are thinking because of database class. Okay, key is looks like always the unique, and this is the primary way to access the data. That was the reason why the relational database is very fast to access the data. But not always our data set data has the unique key. Okay, so in this case, for example, we are going to consider data as a key and value. At this time, key is not the key that you are thinking. Key is a way to find the data. It's just identified. It doesn't have to be unique. It doesn't have to be number. It can be anything. It's a key and the other data are value. It's a key and value. So that's the most difficult part for those who knows the database. Database always we are thinking to find the unique key, then using the key we can access data. Because of that we assign the number, the sequence number for the student ID, student number, and the customer ID, customer number. No, not like this. So here, first thing is in the map reduce, idea is like the divide by the line. The reason is that most of the data, such as the raw data and the document, one of the students asked how Google stored such a number of HTML files to here. Why not? We consider the one page as a sequence of a byte. The next line, another HTML file. So it's line by line. So if you take a look at any TXT file or the plain text file, we have a new line character. New line character is like this one. So new line character, next line going to. So when we store the data using any program language like the C, how can you store the data into the file? We open the file, okay? Print, as print, okay? Or in Java, system.out.print. If you write, it's automatically new line character. It's added, print n, okay? New line character. So it's the next line we can store. Next line. So line by line, first we can recognize the data. Then for each line, so this is the data value. And we assign the offset. It can be whatever. So we assign the offset of the file location, the data value location, like this one is 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 14 is the next offset. Okay? For example. So 0 is the key and this I am a student is the value. Next line, the 14 is the key and I like a baseball value. It's just one example. Key and value. Sometimes we need to do the several times of key and value. Okay? Then we are going to focus on such a value until we find the purpose. For example, in this case, so what we want to do is count word by word. So once we got this one, it's not easy to count. Split by space. Okay? Then this one is the key, I, and value is just assigned 1. And A, M, 1. And A is 1. Student, 1. Key and value. This time, key is word and the value is just 1. Okay? Same thing for the another block. So this one is running and this one will be running. Okay? For this job. This is called the mapping. We assign the job to the block. That is called the mapping. Okay? We don't have to map the all copies, only one best node. Who knows? The naming node. Sometimes it may be possible this one is slow. Then naming node actually intentionally start same job to the another node that has the same block. Let's see what's going on. Which one is faster? If this one is faster, terminate this job. Then keep the output of this. It's called the spectralization. So data had to use such a processing spectralization, then see the performance and select the better one. Okay, so then we will get the output of this one. Before that, even 1 and I is 1. We have the same key. So we are going to order and combine. This one is I, 1, 1. We are not going to add. Because if we add, it's an operation. It needs instruction, I/O. It will take a longer time. Instead, just append. So if 10 times of I in the same block, just 1, 1, 1. Okay? If we add up 10 times of plus, it will consume a lot of instruction, CPU time. In case it's just a simple case, it's okay. But if we have 1 terabyte size, it's really huge. So we do not add, just assign. This is the array of 1, number 1. Then sort. So A probably is the first one, and M, and the I, and the student, like this. 1, in case 2, 1, 1. Like this is called shuffle and the sort. Shuffle and the sort by the key. Okay, so this is output. I will show you the detail. It's just a rough idea. Then we will do the same thing for another second node here. Then output will be sent to the one of the assigned node. Then the combine this output and this output. Okay, so this is called the reducer. And reduce generate the output as a file of HDFS. Then you can get the final output. If you have the 10 block, and then 10 job will be running at the same time. Okay? Then output of each node, 10 output will be merged into the, reduced into the 1. Sometimes you can have the 2 reducer. You can have the 3 reducer. Depends on the requirement, you can change it. Okay? That is the very high level of the map reduce, the framework. Java programming also. It's coded by Java. And a lot of housekeeping job was removed. We don't have to worry about which node you need to access, which block you need to access. The naming node, job tracker. Job is the process. Job tracker knows this one, then assign the job to the task tracker, each the data node. So they are in charge of the processing part. Then output will be combined into the one of the one or multiple node as a reducer. So this is how it works without yarn. In case we have the yarn, yarn is the resource monitoring tool, resource manager. So this time if we do not use the yarn, job tracker, rely on the monitoring of the naming node, like the heartbeat. But it's not fully accessed operating system. How much is CPU each data node is using, and the memory and the source. So yarn is connecting, assign the process based on the resource monitoring. Then this job will take care the job tracker, not its name is not job tracker. Instead of job tracker, this yarn create their own process to monitor and process. We will see the details of that. Can you see? Something. Try rebooting. I need the time to get used to the MacBook interface. Okay. Then view. So this map reduce has the 3 main parts. The mapper. Mapper is assign the job for each data node. Okay, where the specific block is stored. Okay. Then we are going to process based on the key value processing. I will show you the more details of the key value processing, like divide the data block by the line and something item that you want. Okay, until you get the specific data you wanna process. Then the shuffle and the sort the data, mostly something key and the value. Then send such a data to the reducer. Reducer operates like the combined summation or the average and count, something like that. Okay. So for example, this is the input data. So you can see the input data is very similar as what I mentioned. What we want to do is count. So this is our expected output. I think that this is from the Harry Potter, right? So then for example, the is 4 times, and it's alphabetical order because of the during the processing shuffle the data. So this is what we expect here. Then the first, each of them, this one is one block, this is another block. Let's pretend the number of block. Then for each block, the mapper is the task tracker, that one will be running, and the count, this one, the one, cat one, set one, on one, dog one, the map one. And this is a mapping. And another mapping is like this. You can see the key and value. Key and value, key is not really unique. It doesn't matter. Anything that can represent, our goal is count. To represent the value of this one is a word. So this is the key. Okay? Somebody said, MapReduce programming is the designing of key and value. Actually, inside the code is not that difficult. But designing key and value until you got the data, what you want, is the kind of designing problem. Then, after we got this key and value of the mapper, we shuffle and sort. So, we are not going to add up here, okay, just append to reduce the overhead. Then we will get such a thing, which is called the intermediate data, just before sending such a data to the reducer. Okay, so this is shuffle and sort. Then the send to the reducer. So reducer received such a data. Then in this case, the main algorithm of the reducer is what? Adding this value. Okay. In case the is here, another block send the we combine and add. So that is the reducer. So final output here. Final result will be stored at the HDFS also. There might be a way to move quickly, but I'm not familiar with the view first. Okay. So this is the diagram to show the map reduced in terms of data flow. So we have data in the file, and we will split the data by the block like this. Then we read record by record. Record can be represented by the new line in the file. So most of case, the MapReduce start with the split by the new line by line. One line considered as a record. Like the record or the one row in a table in IDBMS. Okay, so we consider the data line by line. Think about the CSV file. Comma separate the value. CSV file. a lot of time when you download the data from the data set, like the UCI data set or the government data set, data.gov or the NOAA, and many of them, they provide CSV file format. Okay, comma separate. You can open such a CSV file using Notepad, any text editor, or the Excel file even. Then they are separated by the comma for each line. So usually one line represents one data, one record. That makes sense. So first we are going to split by the record using new line character. So one line is the data, and we should have the key. So at that time we can use the offset of that record as the key. And if we need to process by word, so word by word split. Then define the key as a word and the value as just one. Later we will count. So that is the mapper. And the partitioner, forget about the partitioner here. So then the shuffle and sort to reduce the overhead of the reducer, then send to the reducer. So you can specify the number of reducer, but in this case 2, but if you have only one reducer, combine, then apply your objective. Like the count is the count this one, value. If you average, you can add up and divide by number of the such a value. So that is the overall flow of the MapReduce. Let me show you the code this time. So this is the mapper. So basically, not basically, the Hadoop, most of the Hadoop system is coded by Java. So Hadoop core, the HDFS, as well as the MapReduce is coded by Java. So we are going to start with the Java program. So next week you will run this code and get the output, but briefly introduce how it works. There are three parts of the MapReduce program. One is mapper, okay, mapper class. Another one is reducer class. Third one, driver. So we need the main class. So main class. You can put all together one file, or the one by one, it doesn't matter, as long as you have the main class driver. So this is a mapper. So you can see it. I'm not going to explain details. Next class, during the exercise, a little bit more detail. The GA, the Babia explained, but you can see the input is the file. You can specify the file. This file should be in the HDFS. Okay, not the local file system, HDFS. Then you can set up the job name. Okay, this job is instantiate, and the input data is from the argument 0. Output will be stored at the HDFS file name. Then we have word. This one is driver. This one is driver. So word mapper and the sum reducer. Probably we have the word, the mapper, the Java file, and the mapper class and the reducer class. It will be here. Then we will key define what is the key, what is the value of the mapper. Okay. So most important part of the MapReduce is defining key and value and check it's not data type actually, but you can understand as the data type of the key and value. It's actually the class, but you can understand as the data type, mapping the data type. So this is the main code driver. So this one is a mapper. What mapper is doing is we divide, split the data until what we want. So what we want is word by word. That's what we want. So we can start this one is the input, the key and value, and output key and value. long writable is the, we don't know whether this is the word by word, and this is a and this one is the value to represent the offset, because we are going to use the offset as the key, and the final output is word and the integer value. So writable. Then you can see the input line by line. So you can see the line and the value to string, the line by line, and split by the word. What is this? This is called functional programming. So if you are familiar with the functional programming, we don't have to define the separate function inside the code. Java supports the functional program from the Java 7. So you can do the functional programming. So if you know very well the regular expression that can handle the data, for example, in this case, line, we are going to line by line. Line is this one, is the value. Value is the here. So we can get the text. So line by line, so we can split by W is the word. The word by word split. Then we can, word the length is bigger than 0. Like we can have the space. Space, A. At that time we don't consider such a 0 length. Then this one word, for each word we can just write the 1 like this. This is a mapper. So algorithm itself is not very complicated. So we use a lot of the same template. So especially if you are familiar with the Python, this one can be easily implemented using the Python. So there is a way to implement the MapReduce using the Python. Later we will see. Then this is a mapper. There is no code, by the way, for shuffle and sort. We just define, and this can be split by the word, then assign the word by 1. That's it. And shuffle and sort will be done automatically. Behind this framework, will do as I said, the main objective of such a header is take out any housekeeping job. Instead, we are going to focus on the algorithm only. Then next, reducer. So this is the output of the mapper. It's an intermediate code like on 1, 1. It means it's 2 times. The set happened 2 times, the happened 6 times. Then the reducer, the main algorithm, it's very simple. Read the key and value and add the what? The value. That's it. So let's see the code. You can see the value plus. That's it. It's very simple. So we can focus on that is the benefit of the MapReduce. We can focus on only the algorithm, logic or business, the logic, rather than such a bunch of the housekeeping. Important thing is you need to match such a input and output data type, the value type. It's very important. Otherwise, it will be error. You will see such a details during the exercise lab the next week. Like the input should be matched with the output, like this. Streaming API. What if I do not know much about Java? Then can I use a Python or the other program? So actually, as I said, the Hadoop and most of the Hadoop ecosystem are coded by the Java itself. So Java is the best way to do the MapReduce programming. But if you have if you know the other program languages, as you can see, if we provide the algorithm plus data type, so it can be translate, converted to the Java program. So output, we specify the logic and the algorithm and the input-output data. Then if we run with the Python, other program language, it automatically convert it to the Java program. That is called the streaming API. So for example, if we are using the Perl, this is not Python example, it's a Perl example. It's a very simple method. Okay, split by the word and stored as the number of words. And for each word, we can assign just the word and the one. /t is the tab. Just one. Very simple algorithm. Then this one will be converted to the mapper program automatically. The behind. Reducer, even the kind of this. So each one, we can get the key and value and split by the it's a tab. Probably at the time it's a tab. In case of a comma, you can use a comma. Then this one is adder. Where is the adder? Yes, the sum of the value. Okay, just the sum of the value for the same key. Then run the program. How can we run the program? So once we have the Java code, in case of Java code, we compile and we have the three class files. One is mapper, reducer, and driver, main class. Then combine with the jar file. Okay. Then the jar file will be submitted to the map reduce. The map reducer use that jar file for the map reduce program. In case of the streaming, we can follow the rule. Let's see. There it is. 8 minutes. Okay, so then the plus, the header, distributed file system, map reduce. Then plus yarn. I didn't explain the details of yarn. Yarn is a resource manager. So instead of using such a job checker, it's very limited. It cannot actually monitor the operating system level. But the yarn can monitor the system level of each data node. They know which one is better, which one is faster, and assign the job and each task for the best one. So that is basically yarn, the resource, the manager. Then plus we have the ecosystem means so we can consider the additional application, Hadoop application. I'd like to introduce very briefly that are being used the Hadoop ecosystem, very popular use. First one is HBase. HBase is one of the most popular, the NoSQL database. It's a key value. We can do many of the jobs using only HDFS file system, but you cannot update, you cannot index. So can I do that? At that time, you can use the HBase. HBase supports such an additional thing on top of the Hadoop distributed file system. That is HBase. We will have a time to talk about the HBase, and also you will practice HBase with the virtual machine later. It's a key value. So it supports the key and value and the sum. The from and the scoop means, so nowadays, as I said, the NoSQL database cannot replace a relational database. Instead, they are working together. Mostly, the NoSQL database or the Hadoop, the system, the Hadoop, the HDFS and MapReduce such a Hadoop system can support not online transaction, the processing job, which means the quick response time. I'd like to reserve the ticket. I'd like to access the bank account. No. Instead, it's a batch job or data warehousing or data analytics. So which means it runs the very long. It processes a lot of data, something like that. So at that time, where do you get such a data source? Sometimes you can get the data from the another node as a log file. Or sometimes you can get such a data from existing relational database. So if you get the data from the relational database, then the put into the HDFS, at the time you can use the scoop. You can see SQL like the SQ, whatever. Scoop means you can scoop the data into the for the HDFS. From is the kind of agent program. We have the something agent program is the source, the node. Then whenever there are the new data in the log and send to the this one, the HDFS. That is the flow. If you go to the Vermont or the main, you can see the from. From is a kind of the string to send the tree log. So it looks like the from. Spark is, I think that you can pay attention to the importance of the Spark. So MapReduce, like the Google, some of the company, they throw out the MapReduce. One of the reason, not easy for those who do not know the Java, okay? And also it's need the programming. But Spark provides very easy interface, like the Python interface. Then you can use the Python to access to do the exactly same thing as the MapReduce for the HDFS. One of the problem of the MapReduce is running on top of only HDFS. Why? What about my data is in the other file system, not HDFS. MapReduce doesn't work. Okay? At the time, Spark, maybe the solution Spark is faster and easy to implement. And also it supports variety of data sources, including HDFS, the other file system. So nowadays, Spark is getting important. So in my another big data course, big data and data analytics, I introduce very briefly about the MapReduce, then mostly the Spark. Then Hive and Pig is for those who do not know the Java programming. MapReduce is difficult. So is there any other way? So Yahoo, for example, they realized the most of the employees, they do not know the Java at the time. So why not implement their own program language interface? Okay, that is called the Pig Latin. So Pig Latin is kind of the simple shell programming. Let me show you one of the example of the Pig Latin. It's not here, unfortunately. Oh yeah, like this one. So process data is loaded from this one, and the filter is the filter out something. So very quickly you can capture the script language. Then behind this script language will be converted to the what? MapReduce behind. It's not very optimized, but it's easy to implement. What about the SQL? I know only the SQL. So such a SQL interface is called a Hive. It's not the SQL database. Actually, behind, if you run this one, it will be automatically converted to the MapReduce program. Surprisingly, such a single one line, the query will be converted into the almost 1,000 line of the Java program, MapReduce program. Problem? Maybe performance, because it's not fully optimized, but very easily. So in the big data course, many of the students use Hive as the programming interface rather than the MapReduce, because it's easy. Then something other like this one is machine learning. The application on top of the Hadoop, they add more and more. But nowadays, a lot of the machine learning, the API, the library, and the package like the Python in the Python, and you can find the machine learning, the library, the TensorFlow library, so a lot. So it's not very highlighted, but still one of the main Apache Hadoop project, so you can find. Okay, so let me stop here today's lecture. Usually it takes several weeks to explain everything of this one, but I briefly introduce. So next week, please download the virtual machine. It will take a time, but usually UV network doesn't take a long time. But if you try to download once we start the next exercise lab, it will be forever because probably a lot of students. Please download your virtual machine, then install the VM player or virtual dock. Okay, if you are using the MacBook or if you are using the Windows, the VM player is working. So whether to download such a player, virtual machine, the player, then to start at least. Start whether your virtual machine is working. Then we will have the first exercise lab for the HDFS, second exercise lab, and the map reducer. During the map reducer, more details we will explain the little bit more details about the mapper, reducer, and the driver program. Any questions? Okay, thanks so much. Today I tried to finish earlier because I spent a longer time the last 2 weeks, but I couldn't. Maybe next week a little bit reduced. Okay, thanks so much. We will see you the next week.